Good morning, guys. We're going to start a new topic today. Our new topic is going to be all to do with sequences. So the first lesson is going to involve recognizing and completing linear sequences. So I'm going to explain what that means in a second. Okay, let's begin by looking at these numbers on our screen. So do we recognize these numbers? Okay, hopefully we do recognize these numbers. These are our 4 times tables, and I'm going to tell you the 4 times tables, and this is an example of a linear sequence. Okay. I wonder if you can guess, what does a linear sequence actually mean? So sequence is, say, like a pattern of numbers that follows some particular rules. What is the rule of this sequence? Well, I'm going to tell you that a linear sequence, that just means that each term increases by the same amount each time. So this word term, that just means a particular number in the sequence. So for example, 12 is the 3rd term in my sequence. Okay, so what's the rule? Well, in the 4 times tables, we know that each term just gets 4 added onto it each time. So to get from my first term to my second term, we add 4 and so on. So a linear sequence means that we're adding the same amount each time. Okay, what about this sequence of numbers? This is a sequence. Do you recognize this sequence of numbers? Okay, well, this sequence of numbers are our square numbers, because 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So these are our square numbers. So now I'm going to ask you, is this sequence linear? So think back to that definition, pause the video if you need some time to think. Is this a linear sequence? Well, let's think about my square numbers then. What is happening each time I increase a term? To get from 1 to 4, I've added 3. To get from 4 to 9, I've added 5. To get from 9 to 16, I've added 7, and so on. So is this linear? Well, the answer is no. The square numbers are not a linear sequence because the terms are not increasing by the same amount each time. These amounts are increasing by a different amount each time. So the 4 times tables would be a linear sequence, and my square numbers would not be a linear sequence. Okay, so keeping in mind what we've just discussed, you have 6 sequences to look at. I want you to answer the questions, which of these sequences are linear, and I also want a reason. If you think they're not linear, give me a reason. Okay, so pause the video, and when you're ready for the solutions, just unpause the video, please. Okay, so my first sequence of numbers, obviously you'll recognize the sequence. It's my even numbers or it's my 2 times tables. And I'm going to tell you this sequence is linear. We know this is a linear sequence because each term gets 2 added onto it each time. Okay, let's try the next one. Okay, what's the actual rule for this sequence? So it's not some particular times tables, is it? So it goes 2, and then 4, and then 8, 16, 32. Can you see what's happening each time there? Okay, so I'm going to tell you this is not a linear sequence because each term does not have the same amount added to it each time. So plus 2, plus 4, plus 8, plus 16, and so on. What we're actually doing, we're multiplying by 2 each time. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. But that does not make it a linear sequence. Even though I'm timesing by the same amount each time, it's only linear if I add by the same amount each time. Okay, so next question. So 10, 8, 6, 4, 2. Can you think what's happening each time? Well, we're starting on 10 and we're taking away 2 each time. So does that make it linear? I'm going to tell you yes, that does make it linear because really I'm adding negative 2 each time. So if it goes up by the same amount or if we're subtracting the same amount each time, that does count as a linear sequence. If it's going down by the same amount, that's absolutely fine. We still call this sequence linear. We're adding negative 2 each time. Okay, 4th question. So we're going 2, 5, 8, 11, 14, and so on. It's not some common times tables that we know, is it? So it starts off with a 2, but it's not the 2 times tables. But what's actually happening each time? Well, to get from 2 to 5, I'm adding 3, and so on. So this sequence is linear. I know it's linear because each term just gets 3 added onto it. So it doesn't have to be some particular times tables. As long as I'm adding the same amount each time, it's a linear sequence. Okay, so next one. Can you predict what I'm about to say? So what's the rule here? So to get from 2 all the way down to -1, I'm taking away 3. To get from -1 to -4, I'm taking away 3 each time. Do we think this is linear? Well, yes, it is. It's a linear sequence because I'm taking away the same amount each time. So if I add the same amount or take away the same amount, that is absolutely fine. Okay, and then last question. So I've got a half, 1, 3 halves, 2, 5 halves, 3. Is this a linear sequence? I'm going to tell you, yes it is. I know it's a linear sequence because I'm adding 1 half each time. If you find that hard to spot, you might want to write these integers as mixed numbers. So really it's 1 half, 2 halves, 3 halves, 4 halves, 5 halves, and so on. This is a linear sequence because I'm adding a half each time. I could have a fraction and I can have decimals. Fractions and decimals are still numbers, so they can still absolutely be a part of a sequence. Okay, so let's move on to our next activity. So I'm going to tell you both of these sequences are linear. Please can you pause the video and see if you can fill in the missing gaps in these sequences. Okay, so the first one's definitely easier than the second question. In the first question, we know it's a linear sequence that must increase by the same amount each time. To get from 4 to 9, well, we have increased by 5, haven't we? Okay, so we know that this plus 5 is going to be consistent throughout the whole sequence. So can you predict what that next term is going to be? Well, if I add 5 to 9, that gives me 14. Then I'll get 19, and then I'll get 24. So I'm adding 5 each time. That rule is consistent, and I've solved the problem. Alright, a little bit trickier. So my second term is 9, and my fifth term is 21. How do I find the first, third, and fourth terms in my sequence? Well, let's focus on the information they've actually given us. To get from 9 to 21, I've added 12. But how many gaps are there to get from 9 to 21? If I draw my little loops like I did in the first question, really, so 9 to get to term 3, to get to term 4, to get to term 5, this is 3 steps. So if 3 steps account for adding 12, what would 1 step have to be? Well, if I take my 12, it's my big step, and divide it into 3 smaller steps like I should do, this tells me that each jump, so each increment needs to have 4 added onto it each time. So I'm adding 4 each time. Let's get from 9 to term 3, I must add 4, so 9 gets to 13, and then I'm adding 4 to get 17 and 21 and so on. And how do I go backwards then? So to get from 9 to my first term, are we happy that if we're doing this the opposite way, I'm just going to take away 4? Yeah, so 9 take away 4 gives me 5, and then thinking forwards again, 5 add 4 makes 9. So that's how I'm going to fill in those gaps. Okay, so your final task for today is attached for you on Google Classroom. So you've got 18 questions, so do as much as you can, please. Can you fill in the gaps? So every sequence on your page is a linear sequence. We know it must increase by the same amount each time. Okay, any problems with that, please just let me know, and I'll be more than happy to help you. All right, thanks very much, guys.